I want to talk about how we make track saws. And so first I want to say what is a track saw. Usually people use circular saws, cutting a straight line rip, not using the track saw, but just a single edge to slide along. I'm not going to actually cut it, but I'll show you the idea. You've got an edge here, and you slide along, and you cut it off. And then usually this line here is a marker of where the kerf is going to be. Now, unlike the conventional demonstration I just did, where there's only one straight line edge, track saws have several, so I want to show that next. The advantage of having multiple straight line edges as saw guides is that prevents the blade from wandering both left and right. Whereas when you only have a single track, it won't wander into the track, but it can wander away from the track, so your cuts won't be as consistently straight. Okay, now this is a track saw. I made it short so it's easier to film. But you notice there's two grooves in it that were formed with a router. And the first groove is this one. And the way that works is you route it, in this case with a 1-inch diameter router bit. And it's designed to take 1-inch wide bars. And this first slot, when you first route it, it's never big enough. So you have to make a second pass to expand it by roughly 1/100 of an inch. And then when you do that, you find out that it fits fairly snug, but still slides easily. And then the second slot here is intentionally made a little bit wider. And you can see, well, you may not be able to see very well, but it's got some wiggle capability in it, and that's intentional. So I said before that conventional ripping with a circular saw involves one straight edge, and I showed how that went. This one has 4 possible straight edges, but in fact we only intentionally use 3 of them. This one, and this outer one. The reason is that this first one, it's trivial to get a fit. You just, like I said, the first time you fit it, it's too tight, and you add just a little bit of an extension to that. That's pretty controllable. For instance, you could add a 5/1000th of an inch correction to that, although maybe 0.01 inch is more typical. This second one, though, once you get to that point, you're not fitting the rod directly anymore. You've got rods on the base of your track saw that have to fit this pair of slots, and the one rod we already established will fit this one kind of as snug as we decide to make it. But this other one is a little bit tricky. If you try to make it, this is already snug, so it's not shifting around. The second bar for the second slot, if you try to make it tight here and tight here, that's a difficult thing to do, and you may not succeed at it. So what we do is intentionally have some slop on this side, so there's a little bit of a gap between this middle edge and the rod that's coming out of the circular saw base. And instead we target having this outside edge be snug. And that gives you this edge, and this edge for forming the 3 tracks that are used for guiding the circular saw. One reason for choosing this outer track instead of this inner track is that there's more stability. The bigger, the wider the footprint. So going from here to here is better than going from here to here or from here to here. So I'm not going to cut this, but if I did, I would. I have a little, I call it a saw guide for getting the saw started easily without requiring a longer piece of wood. So one starts it, you slide along, and then you come out and finish it. So that's what a track saw does. And it turns out that we can do such a good job with the router construction of this that we could even stop halfway along, turn off the engine, turn off the motor, and maybe move some clamps around, then restart the motor and continue on, and you won't see any jog in the cut where we stopped and restarted the motor. Not only there's no teeth marks to be aware of, it turns out that it's dead on straight if you put a straight edge against it. So there's definitely advantages of having a track saw as opposed to a one track, or which we wouldn't call a track saw anymore. So I mentioned how once you've routed a slot, there's an easy way to make it a tad wider, and I want to give you an idea of that here. What we do is we attach with screws some alignment blocks to the track saw piece of plywood, and then use those to anchor. This is supposed to represent a guide for a straight line for passing the router. So if we did let's say the router dimension was such that we formed this slot by this router guide and block formation. What we can do to expand the size of that slot is, in a simple way, just put a playing card here and one here. Let me just show this one. The other one will have duplicate pattern. Playing cards are from a deck of, say, 52 cards, and they're about ½ inch thick. Well, if they were 0.52 inch thick, it would be exactly 0.01 inch per card. So a deck of cards is a good source of 0.01 inch offsets. And then actually that's the biggest offset I tend to want to use. One of about half that size is even better. So I've found some paper that I can measure the thickness of with calipers, and it's about 0.05 of an inch. So if I put both of these in there, that'll shift the next pass of the router over by, well, 1/100 of an inch plus 0.05 of an inch, or 0.015 inches. So that's an easy way to introduce to generate wider routed slots. Sometimes you need going from the first slot to the second slot. This distance is about 2 inches, so you need to be able to make that step. And how do you do that? Well, for instance, you can put these 1 inch wide aluminum bars that were the same bars used for that, and they're 1 inch. So if you do that little trick, you've expanded where the router slot is, not expanded, but move the router slot by 2 inches. And if you wanted to make that slot wider later, you could add a playing card here. This, remember, is glued down, is screwed down, so it's not moving. So in order to add that playing card, you end up shifting all this stuff slightly that way. Alternatively, if you'd already routed this second slot without the card, and if you had used the card for the very first slot, then it turns out the second slot is 1/100 of an inch, 1/100 of an inch closer to the first slot instead of 1/100 of an inch further away. So by adding little shims to these alignment blocks, we can control the location of a slot and also its width. I want to describe how the alignment blocks are installed. The alignment block is this little piece of wood, and we're trying to press it tightly against this aluminum guide, but we don't want to shift the aluminum guide. So the way this is done, first we are ready to apply some horizontal pressure to move the alignment block against the aluminum guide. But before that pressure is actually applied, we have this orange clamp pinching the guide vertically against the plywood base, so that the guide cannot be shifted when we start applying pressure with this black clamp. You'll notice we also have a little C-clamp here starting to pinch the alignment block against the plywood base. So far it's unscrewed, but once we have it in position, we'll tighten these screws and then we'll be able to move around. So now the alignment block installation has been completed. You notice the screws are in tight, and we can now take off all the clamps. We've introduced a routing and an alignment block process for making track saws that has better than 5/1000ths of an inch accuracy in both position and width of the tracks. We've seen that it provides extremely stable saw support, so much so that you can even stop a cut in the middle and then restart it after rearranging clamps perhaps, and you'll have no indication that anything happened. There will be no extra blade marks on the cut, and the cut will be extremely straight. This process promotes extreme adherence to straight lines for even 8-foot cuts, and is probably better than the kind of cuts you can get on most saws. We've introduced a short, what we call saw guide at the infeed end, which allows using an 8-foot track saw made with an 8-foot straight edge to saw 8-foot plywood. You don't need longer than 8-foot alignment edges, for instance. This process has been quite reproducible, and we haven't failed yet, so that's pretty encouraging. I've made a whole bunch of slides in perverse detail, and I don't want to go through them now, but they're embedded at the tail end of this video, and they're also available as a PDF on Google Drive at this link. I'll also put this link in the comments section associated with this video.